Okay, for our last day of vectors, we're going to be talking about the dot product and the angle between two vectors. First, we'll talk about the dot product. The dot product is a scalar operation, which means your answer is just a whole number. I mean, it can be a fraction, but it is a regular number. It has no direction. So you take the x components or the horizontal components and you multiply them together, u1 times v1, and then you take the vertical components and you multiply them together, and then you add them. So you have a number plus a number is the dot product. These are properties of the dot product. They won't surprise you that the dot product is commutative. It has a zero product property. It is associative, and you can multiply it by a scalar. This is the interesting part about the dot product, is that if you dot a vector with itself, you're essentially applying the Pythagorean theorem, because you're saying, let's say that V, sorry about that, I haven't switched pens. There we go. Let's say that V is V1, V2. So you would be taking V1 times V1, which is like squaring it, and you would be taking V2 times V2, which is like squaring it, which is the magnitude squared. So that's just a convenient little property. Here's an example of some dot products. So they're taking the horizontal component, the vertical component, multiplying them, add that together, get the dot product. Horizontal component, 2 times 1. Vertical component, -1 times 2. 2 plus -2 is 0, dot product. Horizontal component, vertical component, 0 minus 6, -6. So dot products can be positive, they can be negative, they can be fractions, and they can be 0. Now the angle between two vectors has a formula. Down here at the bottom, you can see the formula. It says cosine of theta equals u dot v. Let's make a note of that. This is the dot product divided by the magnitude of one vector times the magnitude of the other vector. So here we have two vectors, 4, 3 and 3, 5. On the top, we'll do the dot product. 4 times 3, 3 times 5, add them together, 12 plus 15 is 27. Then we'll find the magnitude of each one by using the Pythagorean theorem. Now that is just cosine theta. That's not your answer. Then you're going to need to go into your calculator and do second cos, or in Desmos, cosine inverse. And that's what you get as far as radians go. You would get a degree answer if you set your calculator to degrees. If we rewrite that expression for cosine theta, we get an alternate form of the dot product, which is u dot v equals the product of the magnitudes times the cosine of theta. So because the magnitudes are always positive, u dot v and cosine theta will always have the same sign. And here's some orientations of the different thetas that you could have. Lastly, two vectors are considered orthogonal if their dot product is equal to 0. And here, very important, the terms orthogonal and perpendicular mean essentially the same thing. They meet at right angles.